Welcome in wireless communication next module. This is the lecture number 2. Dear students, these are the difficult and unforeseen times, and we hope you are taking all safety precautions for yourself and your family. Our wishes and prayers with you. We hope to welcome you in our actual classroom soon. Till then, you have stay in home, be safe, and you attend the online classes. Once again, welcome. In previous classes, in my first module, I have told you what is wireless communication. Wireless communication is transmitting and receiving voice and data using electromagnetic waves in open space, and we have lot of discuss about the electromagnetic waves, and we also know that the information actually the information is main key area where we have to discuss, and this information is mainly depends on the probability of the events. We know about the two ends sharing this information to each other. Suppose we take the how to recognize it is information or not. We know that the sun rises in the east. Probability, if in terms of we have talking, is of course 1, but information everybody knows, so information is nothing, 0. If we take the another example, dog bites a man. If dog bites a man, that is the probability about we take approximate 0.8, and it is the positive information, but it is very less. Everybody knows about the dog bites a man. But if we look about our third example, the man bites a dog, probability of this events is actually very less, is about 2.01. But we have the high information because it is rarer happen, so the probability of those events who's having the high, that's containing the less information in it. So higher the probability, lower the information. Lower the probability means higher the information. In other words, we can say that if the event is unpredictable, uncertain, and having the highly information in it, and this is the today our main topics. First of all is information. So suppose information is defined by capital I, okay, and the probability is denoted by P of I. I takes the integer values 0, 1, 2 and so on, so it's having the relationship I is directly proportional to the P of I. It implies that if we have taken the I in the suffix of information, that is having the relationship equal to log of 1 upon pi. And here pi is the probability, and the important thing is that information can be given as I of I, and we have taken this I. Suppose I is the if we talking about log 1 upon pi, here I is the base. Okay, if the base of this log, I is the integer values, and here the base of this logarithm, if the base of logarithm is 2 or say 10 or e, so the this e of I is certainly change when the base of log base 2 that is the binary, if the base is e 1 upon pi, that is the natural. If the base of log is 10 and it is the decimal, and it is given by 1 log of 10 upon 1 upon pi. So here the communication theory is applied and used in the form of uncertainty, that is known as entropy. Entropy is known as average information per masses, ठीक है. Technically it is the ideal value, or it is denoted by H, or either capital H or either E. So we can write here this entropy is the average information or per masses, right? So technically it is the ideal value, and it is donated by H or capital E. So H is nothing but summation of I is equal to n minus 1 information and product of probability. The information and the product of probability. So the average information can be given by summation of I is equal to 0, it takes the value I equal to 0 to n minus 1, and it is having the product of information and the probability. Probability means chance or events. That means I takes the values 0, 1, 2, 3 and etc. So H can be written as I is equal to 0, n minus 1, and we replace the I of I from the formula number this is formula number 1. This one is the formula number 1. Here I is equal to log 1 upon pi. So we can take these values and put in the equation number 2. Now it is becomes in place of I of I, we can write here log of P of I multiplied by P of I. So rearrange the this equation. Summation of I is equal to 0, take the value n minus 1, P of I log base 2 1 upon P of I. It is the entropy. So what is the unit of entropy? What is the unit of entropy? The unit of entropy is, what is the unit of entropy? The unit of entropy is given by bits per masses. So the when we in previous class we talked the transmitter and receivers are sharing the information, and here we have seen this information is what? Information means the probability of unpredictability or uncertainty that indicates the information, and it is given by the capital I is equal to log of 1 upon pi. Again we have taken the average information in per masses, that is shown by bits per masses, that is the H, and the information that is shown by capital I is log of 1 upon pi. So important thing is that among the this communication, the information is flow from one end to another ends. That means there is a rate of the information. The rate of information means bits per second, or we can say bit rate. It means a bit can be sent in 1 second. In previous communication you already know that what is the baud rate. Baud rate is given by small r upon capital R upon n. See the what is the R? R is the baud rate. R is baud rate. Small r is the baud rate, and this n is the data elements, and further it is given by n is equal to log base 2 L. So it is the binary, and L is nothing but L is level signal element, and n is the data element, or we can say number of data. So the entropy is can be defined in terms of n, and it's also can be data rate can be given in terms of entropy or baud rates. So taking the formula, we have the formula. We know that R is equal to capital R upon N. Okay, so its capital R is the rate of information. The rate of information upon number of data rate capital small n. So R can be written as R is equal to n small n number of data or baud rate, yani it is the product of number of data and baud rates. So what happened? So we can say n is number of data, or h means average information. So it can be replaced. So in the place of n we can write h. Entropy. So formula, the rate of information is the product of entropy and baud rate. So R is baud rate, H is entropy, and this small r is baud rate. Okay, so the thing is formula becomes equation number 3, and it can be easily understand if we choose the one numerical. Suppose an event has 6 possible outcomes with the an event has 6 possible outcomes with the probabilities, that is P1 is equal to 1 by 2, P2 is equal to 1 by 4, and P3 is equal to 1 by 4, and P4 is equal to 1 by 6, P5 is equal to 1 by 36, and P6 is equal to 1 by 32. So find the entropy of the system. Also find the rate of information if there are 60 outcomes per second. Students can be take this problems. They have stopped this video and write them the problems. Or here we have look at this problem. the given that what is given that the rate of information, which is the capital R, and 16 outcomes per second. 16 outcomes per second. So small r is r's number of data, or we have the data elements. What is the data elements are the 16 outcomes per second. So r is 16 outcomes per second. So we know that the r is also the baud rate. So what is the rate of information in terms of entropy? We know that r is equal to h multiplied by r. So entropy is nothing but I is summation of I takes the value from 1 to r. 1 to either how many events are actually taking. This is the 6 possible outcomes and 6 events. So I is started from 1 to 6 is equal to p of I log, it is the binary 1 upon pi, right? So write the expand this and put the all the values together. We write this, okay, 1 upon 1 by 2, 1 by 4 log base 2 upon 1 by 4 plus 1 by 8, okay, 1 by 8, that is equal to log base 1 upon 8 plus 1 by 16, 1 by 16 log base 1 upon 1 by 16 plus 1 by 36 log base 2 1 by 36 plus 1 by 32 log base 2 1 upon 32. It is, I have write directly. Students are calculate. This values is coming 31 by 16